Good day everyone. Let's try to answer some math problem posted on Facebook. And also, special credits to Master Christian Rosano for sharing this wonderful question. So let's start. Here's the question. When the polynomial p of x is divided by x plus 1 multiplied by x minus 5, it has a remainder of 2x plus 3. When it is divided by x minus 5 multiplied by x plus 2, the remainder is 3x minus 2. Now the question is, what is the remainder when p of x is divided by x plus 1 multiplied by x plus 2 multiplied by x minus 5? Now if you want to try this problem, just pause this video, and if you're ready, here's the solution. And I hope you pause this video and let's check if your answer is correct. To answer this question, we will use the concept of division. So it says that the dividend is equal to the quotient multiplied by the divisor plus the remainder. Now in this case, we don't have integer, so the dividend is not an integer, this is not a fraction, it is not a decimal, but the dividend, the quotient, the divisor, and the remainder are all polynomial. So let's start. When the polynomial p of x is divided by x plus 1 times x minus 5, it has a remainder of 2x plus 3. Now in this case, we have the dividend, which is the p of x, we have the divisor x plus 1 times x minus 5, and we have the remainder 2x plus 3. And let's call the quotient as a of x. Now the question is, do we need to know what is a of x and p of x? And the answer is, it doesn't matter. Okay? And also, notice that the divisor is a quadratic because if we simplify this, we have x squared, and the remainder is a linear. Don't forget that the degree of the remainder is always less than to the degree of the divisor. Now let's move on. So the second sentence says that when it is divided, the same polynomial p of x is divided by x minus 5 times x plus 2, the remainder is 3x minus 2. So we have p of x equals b of x times x minus 5 times x plus 2 plus 3x minus 2. Now in this case, the divisor is x minus 5 times x plus 2, therefore the quotient is different. So let's call this as b of x. Now notice that if we let x equal 5, what will happen is this part becomes 0. The reason is it has a factor of x minus 5. Also, on the second equation, this part becomes 0 or gone because it has a factor of x minus 5. So if we let x equal to 5, x minus 5 becomes 0, and 0 multiplied by anything is 0. Also, notice that in both equations, p of 5 is equal to 13 because 2 times 5 is 10 plus 3 will give us 13. 3 times 5 is 15 minus 2 will give us 13. So surely that p of 5 equals 13. Next, if we let x equal to negative 1, so looking at the first equation, this part becomes 0. And the reason is it has a factor of x plus 1. Now it follows that p of negative 1 is equal to 2 times negative 1 plus 3, or simply p of negative 1 is equal to 1. Lastly, if we let x equal to negative 2, this part on the second equation becomes 0 because it has a factor of x plus 2. Therefore, p of negative 2 is equal to 3 times negative 2 minus 2, or simply negative 8. Now we have p of 5 equal to 13, p of negative 1 equal to 1, and p of negative 2 equals negative 8. Now let's focus on these three results. So we have p of 5 equal to 13, p of negative 1 equal to 1, and p of negative 2 equals 8. Again, we have the concept. The dividend is equal to the quotient times the divisor plus the remainder. Now let's have the last sentence. What is the remainder when p of x is divided by x plus 1 times x plus 2 times x plus 5? So in this case, we have p of x equals, so the quotient is different because the divisor is different. So let's call this c of x times x plus 1, x plus 2, x minus 5 plus ax squared plus bx plus c. And this is our remainder. Also notice that the degree of the remainder is less than the degree of the divisor. Next thing to do is we need to use the result. Let's have first p of 5 is equal to 13. Now if we let x equal to 5, this part becomes 0. Now the reason is because it has a factor of x minus 5. So we have p of 5 is equal to 13, and if we let x equal to 5, we have 5 squared or 25 times a plus b times 5 is 5b, and then bring down c. So our first equation is 13 equals 25a plus 5b plus c. Next, we will use p of negative 1 equals 1. So therefore, we need to let x equals negative 1. Again, this part becomes 0 because it has a factor of x plus 1. Now, p of negative 1 is 1, and if we let x equal to negative 1, we have negative 1 squared or simply 1. So we have 1 times a, and then b times negative 1, so we have minus b, and then bring down c. Lastly, we need to use p of negative 2 equals negative 8. So we will do the same thing. So we have this part becomes 0 because it has a factor of x plus 2. So we have p of negative 2 becomes negative 8. And if we let x equal to negative 2, this becomes 4a minus 2b plus c. Now at this point, we will focus on these three equations. Now this is a system of equation in three variables. Now to solve for the values of a, b, and c, we will use elimination method. So we will eliminate one letter at a time. So first thing to do is we need to combine the first and the second equation. So we need to subtract the second equation to the first equation. And we will have 12 because 13 minus 1 is 12. 25a minus a is 24a. 5b minus negative b will give us 6b. And c minus c will give us 0. Now 12 equals 24a plus 6b. Simplify this equation by dividing all terms by 6. So we have 2 equals 4a plus b. Now at this point, we need to combine the second and the third equation. So if we subtract the third equation to the first equation, we get 1 minus negative 8 will give us 9. A minus 4a will give us negative 3. Negative b minus 2b will give us positive b. C minus c will give us 0. So we have 9 equals negative 3a plus b. Now at this point, we need to combine these two results. So if we do that, we get 2 minus 9 will give us negative 7. 4 minus negative 3 will give us 7a, and b minus b will give us 0. So we have negative 7 equals 7a. Now divide both sides by 7, and we get a equals negative 1. Now to solve for the value of b, we will use these two equations. And if we do that, we will get b equals 6. Now to solve for the value of c, we will use these three equations. Now if we use either of the three, we will get c equals 8. Now we have the value of a, which is negative 1, b equals 6, and c equals 8. Now going back to our solution last time, so we have dividend equals to quotient times divisor plus the remainder, and we have p of x equals c of x times x plus 1 times x plus 2 times x minus 5 plus ax squared plus bx plus c. Don't forget what we want. We want the remainder when p of x is divided by x plus 1, x plus 2, and x minus 5. And we know the remainder is in the form ax squared plus bx plus c. But we have the values of a, b, and c. Therefore, the remainder when p of x is divided by x plus 1, x plus 2, and x minus 5, our remainder is negative x squared plus 6x plus, wherein a is -1, b is 6, and c is 8. And we're done.